The branch of mathematics in which we study numbers is called arithmetic. The branch of mathematics in which we study shapes is called geometry. The branch of mathematics in which we study numbers is called arithmetic. The branch of mathematics in which we study shapes is called geometry. In which the branch of mathematics in which we study shapes is called geometry. In algebra, we develop powerful tools for solving puzzles and many problems in our daily life. In algebra, we develop powerful tools for solving many puzzles and problems in our daily life. First of all, constant. What is meant by constant? Constant is a value that does not change. Constant. Constant is a value that does not change. For example, constant is a value that does not change. Here, number of angles of a triangle. Number of angles of a triangle is, for a triangle, there will be only three angles. Angle A, angle B, here angle A, angle B, angle C. Three angles in the triangle ABC. So angle A, angle B, and angle C. 1, 2, 3. There will be only three angles. It is fixed for every triangle. So here 3 is a constant. One more. Number of corners of a quadrilateral. Number of corners of a quadrilateral is, there will be only, for every quadrilateral, there will be only 4 corners, A, B, C and D. It is fixed for every quadrilateral. Here 3 is a constant, 4 is a constant. So 3, 4, 5, -1, -2, pi, e, 1 by 3. All these are constants. Constant is a value that does not change. Now let us see variable. Variable is a quantity that may change within the context of a mathematical problem. Variable. Generally, variables are denoted by the letters generally denoted by the letters X, Y, Z, L, M, N, etc. We can use any of these letters. For example, here I am use matchsticks to form C's. Let us observe number of matchsticks required for C's. Number of matchsticks required and number of C's. I am preparing a table. For one C, I am taking matchsticks. Here, first matchstick, second matchstick, and the third matchstick. If I use 3 matchsticks, I can form a letter C. For one C, we need to use 3 matchsticks. For 2 C's, how many matchsticks we need to use? C. 1, 2, 3. One more matchstick we need to use, that is 1, 2, 3. 1, 2, 3, 4, 5, 6. We need to use 6 matchsticks for 2 C's. Let us see 3 for 3 matchsticks. For 3 C's, for 2 C's, we need to use 6 matchsticks. To form 3 C's. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 matchsticks are required. By this pattern, we can write directly for 5 C's how many matchsticks are required. For 10 C's how many matchsticks we need to write. If you observe, for 1 C, 3 matchsticks are needed. We can write this as 3 is equal to 3 into 1. For 2 C's, 6 matchsticks are required. That is nothing but 2 into 3. 2 3s are 6. For 3 C's, 9 matchsticks are required. We can write it as 3 into 3. 3 into 1 into 3, 2 into 3, 3 into 3. For 5 matchsticks, for 5 C's, how many matchsticks are required? We can generalize 5 into 3 matchsticks are required. For 10 C's, how many matchsticks are required? 10 into 3. If there are n C's, how many matchsticks are required? N into 3, that is 3n. For 1 C, 3 matchsticks, 2 C's, 6 matchsticks, 3 C's, 9 matchsticks, 5 C's, 15 matchsticks are required. For 10 C's, 30 matchsticks are required. For n C's, 3n matchsticks are required. Here n is called variable. N takes different values, 1, 2, 3 or 5 or 10. N takes different values, 1, 2, 3, 5 or 6, 7, 8, 9, 10, like that. So number of matchsticks required for n C's is 3 into n, that is 3n. Here n is called variable. Here variable is a quantity that may take different values, that may change within the context of a mathematical problem. So it is about variable. Let us take one more example. Let us see number of matchsticks required for n L's. Number of matchsticks required to form an else is, let us generalize by taking some observations. Number of else, number of matchsticks required here 1 for to form one L, 1, 2, we need 2 matchsticks. We need 2 matchsticks to form 2 L's. How many matchsticks are required? 1, 2, 3 and 4. 1, 2, 3, 4. 4 matchsticks are required to form 3 L's. How many matchsticks are required? 1, 2, 1 L. For another L, 2 matchsticks required. For one more L, 2 more matchsticks are required. 1, 2, 3, 4, 5, 6. 6 matchsticks are required. For 8 L's, how many matchsticks are required? Here, if we observe, we can find a pattern here in the number of matchsticks according to the required L's. For 1 L, 2 matchsticks are required. You can write it as 2 into 1. For 2 L's, 4 matchsticks are required. 4 can be written as 2 into 2. For 3 L's, 6 matchsticks are required. 6 can be written as 2 into 3. So for 1 L, 2 into 1. For 2 L's, 2 into 2. For 3 L's, 2 into 3. So we can expect for 8 L's, how many matchsticks are required? See, 2 into 8. That means 16 matchsticks are required. For 15 else, how many matchsticks are required? 2 into 15, that means 30 matchsticks are required. For n else, how many matchsticks are required? We can generalize 2 into n. 2 into n, 2 into n we can write as 2.n. 2 into n, or we can write 2n. All these are the same. 2 into n, 2 into n, 2 into n, 2n. So number of matchsticks required 2n to form n else. So number of matchsticks required to form n else is 2n. Here n is a variable. Here n is a variable. N can take any whole number. N may be 0, 1, 2, 3, 4, 5 and so on. So n varies. N is taking different values. Here n is a variable. Variable is a quantity that may change within the context of a mathematical problem. See, number of else, number of matchsticks required to form 25 else is dash. We have for n number of matchsticks required is 2n, so that we can use this expression 2 into n. 2 into n place we can substitute 25. 2 into 25. To 25 is 50. So that number of matchsticks required 50. 2 into n, that is 2 into 50. So 2 into 25, n plus 25. Number of matchsticks required to form 25 else is 2 into 25. So 50 matchsticks are required. Since letters stand for numbers, operations can be performed on them as a numbers. Since letters stand for numbers, operations can be performed on them as on numbers, like addition, subtraction, multiplication, division, this kind of operations. How we perform on numbers, in the same manner we can perform on variables also. Now let us take one more example. Inside, if the cost of a book, if the cost of a book is, if the cost of one book is 5 rupees, what will be the cost of n books? That is 5 n into 5. That means n into 5 rupees. That is, we can write it as rupees 5n. 5 into n, nothing but 5n. This expression helps us to find cost of different number of books. Let us write number of books and cost. Cost of one book, cost of 4 books, cost of 10 books, cost of 25 books. See, here cost of one book is 5 rupees. Then what is the cost of 4 books? We have cost of n books is 5n. The expression is 5n. Here we can use number of books n. N place we can write 4. That means 5 into 4. 5 4 20 rupees. Whereas 10, n value is 10. See, cost of 10 books is cost of n books is 5n. 5n rupees. Here n value is 10. 5 into n value 10 rupees. N value 10. Number of books 10. So 5 times are 50. So 50 rupees. Cost of 10 books is 50 rupees. Whereas cost of 25 books, we have expression 5n. Cost of n books expression is 5n. 5n rupees. That is 5 into number of books n is 25. So 5 5 is 25. I do 10 plus 2 12, 125 rupees. So based on this expression, we can find cost of required number of books in various cases. A variable allows us to express relations in any practical situation. A variable allows us to express relations in any practical situation. Let us take an example. Samata and Mamata together have 10 marbles. Samata and Mamata together have 10 marbles. Together they have 10 marbles. We don't know how many marbles are there in each one hand. Here, Samata, in her hand some marbles are there, and in Mamata hand some marbles are there. We don't know how many marbles in Samata hand. Let me take number of marbles in Samata hand x. Number of marbles in Mamata hand as y. Together they have 10 marbles. In this situation, we can write number of marbles with Samata and number of marbles with Mamata as x and y. We expressed as x and y. Together x plus y we can take as 10. X plus y is equal to 10. That means marbles in Samata, in the hand of Samata, the marbles in the hand of Mamata together should be 10. So that if there is a one marble in Samata hand, there will be 9 marbles in Mamata hand, together 10. So that X and Y, if I take like this, in Samata hand 1 marble, then number of marbles with Mamata 10. If there are 2 marbles in Samata hand, there will be only 8 marbles in Mamata hand. Why? Because 2 plus 8 is 10. So if X value is 2, then Y value is 8. If there be 3 marbles in Samata hand, number of marbles in Mamata hand 7. Why? Because 3 plus 7 is 10. So X value 3, then Y value is 7. 3 plus 7, 10. If there be 6 marbles in Samata hand, there will be only 4 marbles in Mamata hand. 6, because 6 plus 4 is 10. If X value is 6, then Y value is 4. Here X is taking different values. Here in this case Y is taking different values based on X. So here X and Y are variables. Here X comma Y are variables. Variable is a quantity that may change within the context of a mathematical problem.